everyone. In the last lesson, we learned how to solve exponential equations. So today's lesson is going to be how to solve logarithmic equations. So just like in the last lesson where we practiced identifying the inverse of a function that was exponential, I now want you to practice finding the inverse of a function that's logarithmic. So I would like you to please go ahead and start this warm-up by finding the inverse of f of x equals log base 3 of x minus 1 plus 4. When you have an answer, I want you to restart the video and then we'll see how well you did. Okay. In order for you to find the inverse of a logarithmic function, the first thing that you need to do is you need to get the logarithm alone. So I have this plus 4 on the outside, but before I even do that, I need to switch my x and y values. So I'm going to rewrite this as x is equal to log base 3 of y minus 1 plus 4. So my goal is to get y alone, and in order for me to do that, I need the logarithm to be alone first. So I'm going to start off by subtracting 4 on both sides. By doing that, I have x minus 4 is equal to log base 3 of y minus 1. Now, I can't add 1 to both sides because I'm technically taking the log of it. And I can't divide both sides by log of 3 because that's really awkward. You can't divide by an operation. So therefore, I'm stuck. And whenever you get stuck, you always have to change to the other form. Now, our other form, you have to make sure that you remember that if you have b to the x is equal to y, that's equivalent to log base b of y equals x. So I'm going to go back and forth in between my two forms. I'm going to rewrite this in exponential form. My base is 3. My exponent is my answer. So we had b to the x, and my answer was x when I had it in logarithmic form. So I'm going to write 3 to the x minus 4 power. That's going to be equal to my answer, and my answer is going to be y minus 1. Now I'm going to add 1 to both sides. So when I add 1 to both sides, I now have 3 to the x minus 4 power plus 1 is equal to, and since y is alone, I can now write this using inverse notation. So my answer is y equals 3 to the x minus 4 power plus 1. Now, it's very important that you know how to go back and forth in between your forms because that's going to help you in today's lesson when solving these logarithmic equations. So today's learning target, is to be able to say, I can solve logarithmic equations using exponential relationships and the properties of logarithms. And I'm also going to have a real-world problem that I want you to be able to solve involving a natural log. So I want you to be able to say, I can solve real-world problems involving natural logs. So what is a logarithmic equation? Well, a logarithmic equation is simply an equation that involves logarithms of variable expressions. So a property that I need you guys to know that's very similar to what we learned in our last lesson, but it's going to be a little bit different because it pertains to logarithms, is that if you have log base b of x is equal to log base b of y, where you have both of the logs are the exact same, the bases are the same, then what you can do is you can drop the logarithms and just set x equal to y. So for example, if you have log base 3 of x is equal to log base 3 of 8, the log base 3's will cancel out on each side and x equals 8. And also, if you have x is equal to 8, then log base 3 of x has to equal log base 3 of 8. So if you have an equation where you have a logarithm on each side, and you're taking the logarithm of the same base, you can drop the logarithms and set what you're taking the logarithm of equal to each other. Now, here's the thing that's very important. It says if b, x, and y are positive numbers. So this is going to become very important, especially whenever we check our answers. Your base has to be positive. what you're taking the logarithm of has to be a positive number, and your logarithm needs to equal a positive number. So whatever you're taking the base of, or whatever your base is, and whatever you're taking the logarithm of, have to be positive numbers. So if you see, I'm just going to put it up here in the space for more warm-up. If you see a log base b of y is equal to x, if you see that your base is a negative number at any point in time when you're solving these problems, or if you are taking the logarithm of a negative number, if either one of these are negative, automatically your answer is no solution. However, if x is positive or if x is negative, whatever your answer is, this can be positive or negative. So it can be both. It can be positive or it can be negative. But if any of these two pieces that are attached to the log, if either one of them is negative at any point in time, you automatically have a no solution situation right there. So let's go ahead and hop into solving these equations. So looking at letter A, we have the log base 7 of 6x minus 16 equals log base 7 of x minus 1. So for this equation, we have a logarithm on both sides. And because we have a logarithm on both sides and the logarithms are alone, there's nothing that's attached to them, no numbers out like on the outside, nothing like that. Because we have that, we can drop the logarithm and simply set 6x minus 16 equal to x minus 1. So now we'll solve for x, and I'm going to subtract x on both sides and add 16 to both sides, doing multiple steps in one step. I end up with 5x is equal to 15. Dividing both sides by 5, I find that x is equal to 3. So now I'm going to check my answer using the original problem, and I'm going to write log base 7 of 6 times 3 minus 16. Is that equal to log base 7 of 3 minus 1? So we have 6 times 3 is 18, and 18 minus 16 is 2, so this is log base 7 of 2, is equal to 3 minus 1, which is 2, log base 7 of 2. Both of these numbers are the exact same, so therefore x equals 3 is our solution. Now for today's lesson, I forgot to let you guys know, there's going to be a lot of work that you'll need to show for some of these problems, so please make sure that you are very organized with how you show your work in the notes today. All right, let's go ahead and look at letter B. For letter B, I don't have a logarithm on both sides, and there's nothing on the outside of log base 5 of 3x minus 8. So because there is nothing that I can do in order for me to get x alone, I can't add both sides, I can't add 8 to both sides since technically we're taking the logarithm of it. What we need to do now is whenever you get stuck, we need to change it to the other form. So we're going to change this to exponential form. So we change it to exponential form whenever there is not a log on both sides and your logarithm is alone. So what I mean by alone is that there's no addition or subtraction or multiplication or division on the outside of it. So changing it to exponential form, my base is 5, my exponent is my answer, so that's going to be 5 squared, is equal to 3x minus 8. Now I can solve for x because this is now going to be where I can add 8 to both sides, and that's 25 plus 8. And 25 plus 8 is 33 equals 3x. Dividing both sides by 3, we find that x is equal to 11. So now I'm going to check x equals 11 back into my original problem. I have log base 5 of 3 times 11 minus 8, is that equal to 2? So I have log base 5, 3 times 11 is 33, and 33 minus 8 is 25. Is that equal to 2? Well, it does equal 2 because technically if we were to rewrite this logarithm in exponential form, this is 5 squared equals 25. And 5 squared does equal 25, so it does end up working So x equals 11 is our answer. So now I'm on to letter C, and notice that you should have a lot of space left over if you were showing your work very similar to mine, and you're going to need a lot of space for letter C. So in this problem, we have 2 logs on one side. Now technically you could bring one of the logs over to the other side, but we still wouldn't have both logarithms being alone. So in this case, whenever you have 2 logs on the same side, separated by addition or subtraction, what you want to do is you want to condense your logs. So when you condense your logs, we know that if 2 logarithms are separated by addition, we're going to multiply, we're going to use multiplication in order to condense. So this is going to be log of 5x times x minus 1 is equal to 2. So now that we have this as a log alone, and there's nothing for us to really do at this point, other than to maybe distribute the 5x to each term if you want, we need to change this to logarithmic form, or change this to exponential form. So that's exactly what I'm going to do. I'm going to change this to exponential form, where my base, whenever you don't see a base, that typically that base is the number 10. So this is going to be 10 to the 2nd power is equal to, I'm going to distribute that 5x to each term, and so we end up with 5x squared minus 5x. So now this is a quadratic equation, and I'm going to rewrite this as 10 squared, which is 100, is equal to 5x squared minus 5x. And I want all quadratic equations to equal 0, so I'm going to subtract 100 on both sides. And when I do that, I end up with 0 is equal to 5x squared minus 5x minus 100. Now, 5x squared, 5x, and 100 all have in common a 5. So I'm going to factor out a 5. And I'm left with x squared minus x minus 20. So now I'm going to break down the x squared minus x minus 20 into 2 parentheses. Splitting apart the x squared into an x and an x, I need to ask myself what 2 numbers multiply to equal negative 20, but together add to equal negative 1. And that's going to be a negative 5 and a positive 4. So now my 2 solutions are x equals 5 or x equals negative 4. And that means that I'm going to have two parts of my problem where I'm going to be checking. We would not have it be 0 since that 5 doesn't have a variable attached to it, so that 5 is just kind of there. So our 2 solutions are 5 or negative 5, and you have to check both. So now I'm going to check x equals 5. And I'm going to plug it back into the original problem. So I'm going to write log of 5 times 5 plus log of 5 minus 1, is that equal to 2? So 5 times 5 is 25, and 25 times, because I'm going to condense, because we have ourselves addition, so I'm going to condense using multiplication. 5 minus 1 is 4, so 25 times 4, is that equal to 2? So we have log of 100, 25 times 4 is 100, is that equal to 2? Well, yes it is, and that's because 10 squared is equal to 100, if I were to put that back into exponential form. So x equals 5 works. So now I'm going to try to check x equals negative 4. So I'm going to write log of 5 times negative 4 plus log of negative 4 minus 1, is that equal to 2? Well, I have log of negative 20. I'm going to stop right there. And that's because I have a negative 20. And I just said to you guys that if you see a negative that's next door to any sort of log, where you've had to substitute something in and now you're taking the logarithm of a negative, or your base suddenly becomes negative, then that means that you automatically have a no solution situation. So x equals negative 4 is out, and x equals 5 is your answer. So if you see it, I don't even have to continue. Once you have a negative next door to a log, you're done. The story's over. If you had noticed that right here at the very beginning, that you're going to have a negative, then you don't even have to continue. All right, let's go ahead and look at letter D, letter E, and letter F. If you want to try these problems on your own, that might be a good thing, just to see if you know what you're doing. If you want to pause the video and try D, E, and F on your own, go for it. Otherwise, sit tight and we'll go through those problems together. Okay, let's go ahead and look at the next example. In this problem, I have log base x of 25 is equal to 2. There's no other logs on any side. There's nothing for me to really do. I can't divide by 25 and since I'm taking the log of it, so therefore I'm going to change this to exponential form. So changing it to exponential form, I'm going to rewrite this as x squared equals 25. So now this is a nice little quadratic equation. In order for me to get x alone, I'm going to take the square root of both sides, and I end up with two solutions, x equals plus or minus 5. Because remember that whenever you're taking the even root of both sides and solving an equation, you're going to end up with two solutions. So we have plus or minus 5. So that means that x equals 5 or x equals negative 5, and we will need to check both answers. So I'm going to check x equals 5 first, and I'm going to write is log base 5 of 25 equal to 2? Well, yes it is, and that's because 5 squared does indeed equal 25. So therefore, x equals 5 is a solution, and it does work. So now we're going to check negative 5. And I'm going to write log base negative 5, and I'm going to stop right there because there's a negative attached to a log. Automatically, it does not work. Therefore, x equals negative 5 is not our answer. Please note that just because you end up with a negative answer as one of your possibilities does not necessarily mean that that's the one that's automatically going to be no solution. So you always have to make sure that you check your answers along the way. Let's go ahead and look at the next one. For letter E, we have a natural log on both sides, so we have a logarithm on both sides, and what's really nice about that is that the logarithms are alone on both sides, and because of that, the logarithms essentially cancel out. So therefore, we're left with 7x minus 13 is equal to 2x plus 17. And so I'm going to solve that equation for x by subtracting 2x on both sides and adding 13 on both sides. And I end up with 5x is equal to 30. And then dividing both sides by 5, I find that x is equal to 6. So now I'm going to check x equals 6. So when I check x equals 6, I'm going to write the natural log of 7 times 6 minus 13. Is that equal to the natural log of 2 times 6 plus 17? So 7 times 6 is 42, and 42 minus 13 is 29. So this is the natural log of 29. And 2 times 6 is 12, and 12 plus 17 is also 29. So therefore, x equals 6 is our answer. All right, let's go ahead and look at our next one. For our next problem, we have two logarithms on the same side. And technically, you could bring one of the logarithms to the other side, but it wouldn't be alone. So therefore, there's no reason to bring that log to the other side. So therefore, whenever you have addition or subtraction in between logs, we need to condense the logs. So in order to condense, that means condense whenever you have two logs that are being added together, we are going to multiply, use multiplication. So when I condense, I'm going to rewrite this as log base 6 of x minus 9 times x. And that's going to equal 2. Now, if you want, you can distribute that x to each term at the stop, or you don't have to. It just depends on what you see. But the logarithm is alone. And because the logarithm is alone and there's nothing for us to do to get x alone, what we're going to do is we're going to change this to exponential form. So that's what I'm going to write right here. We're going to change to exponential form. So when I change this to exponential form, my base is 6, my exponent's 2, and this is going to equal, now I'm going to distribute that x to each term, and I'm going to write this as x squared minus 9x. So 6 squared is 36, so I'm going to write that as 36 is equal to x squared minus 9x, and because this is a quadratic equation, I need it to equal 0. So I'm going to subtract 36 on both sides. And I now have 0 is equal to x squared minus 9x minus 36. So now that I have x squared minus 9x minus 36, I now need to factor it in order for me to come up with my solutions. So I'm going to break this quadratic down into two parentheses, splitting apart the x squared. Excuse me. All right, splitting apart the x squared into an x and an x. And I need to figure out what two numbers multiply to equal negative 36, but together add to equal negative 9. A lot of us like to go straight to 6 and 6, but in this case, 6 and 6 won't help us. So we have to think of other factors of 36. Now, other factors of 36 are like 2 and 18, but 2 and 18 won't give us a 9. Then there's also 3 and 12. Now, 3 and 12 can get us a 9, so I'll write a 3 and a 12, but I need a negative 9. So that means that I need 3 to be positive and 12 to be negative. So therefore, my solutions are x equals negative 3 or x equals positive 12. So I'm going to check both of these answers. So when I check, I'm going to check x equals negative 3 first, and I'm going to write log base 6 of negative 3 minus 9 plus log base 6 of negative 3. And I'm going to stop right there. I'm not even going to write anything more because I have a negative next door to a log. And as soon as you see that, automatically that value does not work, automatically no solution. So now I'm going to check the other one just to verify that 12 actually works. So I'm going to write log base 6 of 12 minus 9 plus log base 6 of 12, is that equal to 2? So 12 minus 9 is 3, and I'm going to condense using multiplication, so this is log base 6 of 3 times 12, is that equal to 2? Now 3 times 12, that's 36. Is log base 6 of 36 equal to 2? Well, yes it is, and that's because 6 squared does indeed equal 36, going back and forth between the forms. So therefore, x equals 12 is our answer. And that's our only answer. We have 3 more problems on the back page that are just like letters D, E, and F, and if you want to try those problems on your own, I encourage you to do so. Just make sure that you leave a little bit of separation of space for all 3 of them. But we have G, H, and I, which are even more practice. So if you want to pause the video at this time and try letter G, letter H, and letter I on your own, I strongly encourage you to do so. And then we have one more story problem, and then we are finished. All right, let's go ahead and look at letter G. For letter G, we have a logarithm alone. And because we have a logarithm alone, without anything for us to do, what I'm going to do is I'm going to change this to exponential form. So I'm going to rewrite this as 3 to the 3rd power, and that's because my base is 3, my exponent is 3, and that's going to equal 2x plus 9. 3 to the 3rd power is 27, and that's going to be equal to 2x plus 9. I need to get x alone, so I'm going to subtract 9 on both sides. And when I do that, I end up with 18 is equal to 2x. Dividing both sides by 2, we find that x is equal to 9. So I'm going to substitute 9 back into the original problem. And I'm going to write log base 3 of 2 times 9 plus 9, is that equal to 3? Well, 2 times 9 is 18, and 18 plus 9 is 27. Is log base 3 of 27 equal to 3? Why, yes it is, and that's because 3 to the 3rd power is equal to 27. So therefore, x equals 9 is our answer. Next, we have letter H. And letter H, we have log base 6 of x minus 5 is equal to 2 times log base 6 of x. Now, technically, I have a logarithm alone on one side, but I don't have a logarithm alone on the other. And whenever you have logarithms on both sides, but you don't have a logarithm alone, what you need to do is you need to bring all logs to the same side. There's no point in having them on separate sides if you can't simply drop them. The only way that you can drop your logarithms on both sides is if they're logarithms that are alone. And logarithms that are alone don't have addition, a subtraction, or any sort of multiplication attached to them. And in this case, we don't have a logarithm alone, and we can't come up with a logarithm alone on one side. So therefore, I'm going to start off by adding log base 6 of x to both sides. And by doing that, I'm now going to have log base 6 of x minus 5 at plus log base 6 of x equals 2, because the log base 6's of x would cancel out. Now, at this point, since I have two logs on the same side, what I'm going to do is I'm going to condense the logs. And when you condense the logs, we're going to use multiplication when we condense. So I'm going to rewrite this as log base 6 of x minus 5 times x is equal to 2. At this step, if you want to distribute that x to each term, feel free to. That's not a problem. Or you can simply rewrite it and FOIL a little bit later in the problem. It's whatever makes you feel more comfortable. But at this step, we can't get that logarithm, we can't get the x's alone. So what we need to do is we need to rewrite in exponential form. So just like we had up here, I want you to change it to exponential form. So I'm going to rewrite this as 6 to the second power is equal to, and now I'm going to distribute the x to each term. And we have x squared minus 5x. So now what I'm going to do is I'm going to square 6 to make that 36. So I have 36 is equal to x squared minus 5x. And because this is a quadratic equation, I'm going to make it equal 0 by subtracting 36 on both sides. So now I have 0 is equal to x squared minus 5x minus 36. So now I'm going to split the quadratic apart into two parentheses, splitting apart the x squared into an x and an x. And I have to think about what factors of 36 multiply to, or what two numbers multiply to equal 36, but together add to equal negative 5. So we start at the beginning. 2 and 2 and 18 when added or subtracted will not give us a 5. So then we look at 3 and 12. But 3 and 12 can get us some kind of 9 or 15, but not a 5. So the next number is 4. 4 and 9. 4 and 9 could work. I can put down a 4 and a 9, and we can make that a negative 9 and a positive 4. And 4 minus 9 does indeed equal negative 5. So therefore, our solutions are x equals negative 4 or x equals positive 9. And you need to make sure that you check both. So that's exactly what I'm going to do. I'm going to go back to the original problem, and I'm going to check x equals negative 4. So I'm going to write log base 6 of negative 4 minus 5. Is that equal to 2 minus log base 6 of negative 4? Okay, if you notice right away that we would have ended up with a negative 9 right here, then you wouldn't have had to keep going. But right here we have log base 6 of a negative number. Both spots, no solution. That tells us x equals negative 4 is not going to be one of our answers. So now we're going to check x equals 9. So I'm going to write log base 6 of 9 minus 5. Is that equal to 2 minus log base 6 of 9? So I'm going to write log base 6 of 4. Is that equal to 2 minus log base 6 of 9? So I'm going to bring both of my logs to the other side, or bring my log to the other side so that I can condense. So when I add log base 6 of 9 to both sides, I'm adding, so I'm going to condense using multiplication. 4 times 9 is 36. So I have log base 6 of 36. Is that equal to 2? Well, yes, it is, and that's because 6 squared equals 36. So therefore, x equals 9 is our answer. And we have one last example of solving these equations before we have a story problem. So for this problem right here, we have two logarithms. We have a logarithm on one side and a logarithm on the other, but this logarithm is not alone. So the logarithm on the right-hand side is not alone. So therefore, what we want to do is, just like we did with letter B, we need to bring all logs to the same side. So that's exactly what we're going to do, just like what we did in letter H. So I'm going to subtract I have this exponent on the outside, so I'm going to bring that 2 over. So I notice that I have a 2 that's on the outside, so I can make that an x squared. And I'm going to subtract log base 3 of 2x minus 5 on both sides. So I'm doing multiple steps in one step. And I'm left with just a 2 on one side. So now I have log base 3 of x squared minus log base 3 of 2x minus 5 equals 2. So now what I'm going to do is I'm going to combine using division, because I have a subtraction sign right there. So I'm going to rewrite this as log base 3 of x squared divided by 2x minus 5, and I'm going to set it equal to 2. So now I'm going to rewrite this using exponents, rewriting it in exponential form. So I'm going to write this as 3 squared is equal to x squared divided by 2x minus 5. So 3 squared is 9, so I'm going to write that as 9 equals x squared over 2x minus 5. Now this looks kind of complicated, but what I want you to do is I want you to make 9 a fraction over 1, and we're going to use cross product. So now I'm going to have x squared is equal to 9 times 2x minus 5. I'm going to distribute that 9 to each term, and I have x squared is equal to 18x minus 45. Since this is a quadratic equation, what that means is I need to bring everything over to the side where the exponent is positive. So I'm going to subtract 18x on both sides, and I'm going to add 45 to both sides. By doing that, the 18s and the 45s cancel out, and I am left with x squared minus 18x plus 45 is equal to 0. So now I'm going to factor this into 2 parentheses and make it equal 0. So splitting apart the x squared into an x and an x, I need to figure out what 2 numbers multiply to equal 45, but together add to equal negative 18. And that's going to be negative 15 and a positive 3. Negative 15 times positive 3 is 45. I'm sorry, not a positive 3, negative 3, excuse me. A negative 15 times a negative 3 is a positive 45, but together they add to equal negative 18. So I have 2 solutions, x equals 15 or x equals 3, and I'm going to check both of them into my original problem. So I'm going to check 15 first, and I'm going to write 2 times log base 3 of 15. Is that equal to log base 3 of 2 times 15, I'm just going to do it in my head because I'm running out of space. 2 times 15 is 30, and 30 minus 5 is 25. Is that, and then plus 2. So I'm going to bring my logs to the other side. And remember that this 2 on the outside is like an exponent. So I'm going to rewrite this as log base 3 of 15 squared, which is 225. And I'm going to subtract it from log base 3 of 25. Is that equal to 2? So now, because I'm going to condense the subtraction by using division, I'm going to divide 225 and 25. So I have log base 3 of 225 divided by 25, and that equal to 2. Well, 225 divided by 25 is 9. So I have log base 3 of 9. Is that equal to 2? Well, yes, it is. 3 squared is indeed equal to 9. So that means that x equals 15 is a solution. So now I need to verify that x equals 3 is a solution. So I'm going to check that. And I'm just going to go right into the next problem. So I'm going to check x equals 3. And I have 2 times log base 3 of 3. Is that equal to log base 3 of 2? I'm going to do it really quick in my head just to save some space. 2 times 3 is 6. And 6 minus 5 is 1 plus 2. So I'm going to make this an exponent. So 3 squared which is going to be 9. So I have log base 3 of 9. And I'm going to subtract the log base 3 of 1 to the other side, and I'm going to see, does that equal 2? So whenever you combine subtraction, we're going to use division, and 9 divided by 1 is 9. So that's going to be log base 3 of 9. Is that equal to 2? And once again, it does. 3 squared does indeed equal 9. So therefore, both solutions actually work. So in this case, we have two solutions. X equals 15 or X equals 9. Or sorry, X equals 15 or X equals 3. All right, we have one last example and then we are finished for this lesson. So let's go ahead and look at example number 2. It says the population of deer in a forest preserve can be modeled by the equation P is equal to 50 times 200 times the natural log of t plus 1. So I'm going to rewrite that because I know that it's very tough to read on my paper. So this is P is equal to 50 plus 200 times the natural log of t plus 1. And that is where t is the time in years from the present. We want to figure out in how many years will the deer population reach 500. So we want the population to reach 500. And population is P. So we want to let P equal 500. So I'm going to substitute 500 in for P, and I'm going to solve for T, because we want to figure out how many years, how long will it take. So I'm going to write 500 is equal to 50 plus 200 times the natural log of t plus 1. So since this is a logarithmic equation, what I need to do is I need to get the natural log alone. So the way I'm going to start this problem is I'm going to start off by subtracting 50 on both sides. And I end up with 450 is equal to 200 times the natural log of t plus 1. Instead of making 200 an exponent, which can be very complicated, I would strongly recommend that you simply divide both sides by 200. That way we have our natural log alone, and it's a little bit easier to work with. So now I have, I can cancel out a 0, and we have 45 over 20 is equal to the natural log of t plus 1. So now that I have my natural log alone, we can simplify 45 over 20. That's a little bit easier to simplify. 45 and 20 both have in common a 5. 45 divided by 5 is 9. 20 divided by 5 is 4. And so we have 9/4 is equal to the natural log of t plus 1. So now I'm going to change this to exponential form. And whenever you're changing a natural log to exponential form, our base is going to be the letter E. So I'm going to rewrite this as E to the 9/4 power is equal to t plus 1. I want to get t alone, so I'm going to subtract 1 on both sides. So I'm going to put e to the 9/4 power minus 1 into my calculator, and that's going to equal my number of years. Now, we want to round our years to the nearest whole year, so I'm going to put natural log of e to the 9/4 power, and then I'm going to write minus 1, and that is 8.48. So 8.48 is approximately 8 years. So that means in approximately 8 years, the deer population will reach 500. And that is the end of this lesson. If you have any questions over anything, please make sure that you email me. Otherwise, I will talk to you next time.